So we get, plug that in and you'll get your answer. So this is a projectile motion problem, right? So then I use x equals vxt, y equals vyt, plus 1/2 at squared. That's 0, so I get t is equal to the square root of 2y over g. And they give me the height, which is 1.2 meters, so I can figure out the time, and then I can plug it back into here to get the distance, because I know this, because x is going to equal vb prime times t. Part C is a vector problem. It is a vector problem. So then you have this vector coming in, which is MA VA, and then you have target ball C strikes the floor at point P, so C comes off like this. This is MC VC like prime, because that's a final, and this is 30 degrees. Okay, so calculate the speed of VC immediately after the collision. Well, do you realize that this time t, the time for this to hit the floor is that? Everyone realize that? Because the ball fell the same distance, same table. So VC prime is just 50 meters. And part D, so sorry, part C wasn't actually a vector problem. It was just V equals x over t. It's an average velocity problem. Now, part D, calculate the y component of incident ball's A's momentum after the collision. So you know that A, because momentum, Pi equals Pf, and that's in the x, and Pi equals Pf in the y. Both are true. So whatever this component is, this component must be. So this is like VC y prime. VA y prime has to equal the same thing. So basically it's a vector problem. So MAVA like this, and that has to equal, and this is MCVC prime, and this is MAVA prime. This is going to equal the vertical part down of that. Those, the yellow and the white one, have to cancel out. So if I, and V1 prime Y, V2 prime Y, V1 prime X, V2 prime X. V2, the two X components add up to be V1. And then the V1, the Vy components have to be equal and opposite in order to conserve momentum. Oh, sorry, this should be momentum. It's not just velocity, it's momentum. So again, the one ball comes in, bing, these two things pop off. When they bounce off, the two momenta that are created have to add up to do. To see, it's like whatever, some force stuff would be 3, but it's 59, whatever. Okay, for this one, so we got basically, can you picture this in your head? Remember, I cannot express to you how important it is that you be able to picture these problems in your head. You must be able to see them. If you can't see what's happening, then there's no hope for you to figure out what's happening mathematically. So you have to see it. So can you see, comes in, hits this, and then what is true? We always say that PF, that is always true. Because this says that they collide perfectly elastically, what else can we say? Which you cannot say for an inelastic collision. Yeah, this is did you remember what you are supposed to remember? And that is for inelastic collisions, kinetic energy is not conserved. Kinetic energy is not conserved for inelastic collisions when they stick together. But for elastic collisions, it is conserved. So, does everyone see the problem here? That we have two unknowns? We have V2 final. I don't know why I don't. Right? So this one says M1V1 plus M2V2 equals M1V1 prime plus M2V2 prime. If you want to do, well, is that better? It's one less tick of the pen, so whatever. Then over here, of course, we have 1/2 mv1 squared, or m1v1 squared, plus 1/2 m2v2 squared equals 1/2 m1v1 final squared plus 1/2 m2v2 final squared. Oh yeah, if you use the prime thing, when you square the things, it gets a little weird, so maybe final's better. And of course, bing, 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 bing. We can get rid of all of those, right? All of that stuff. If you want, you can play this game too. And this game is M2 is equal to 4M1. You see what I mean by that? So then by doing that, I get M1V1 plus 4MV2 equals MV1 final plus 4MV2 final. And now I can cancel the M's here. Tenryu. Oh, that is at least not a senior, thank God. All right. MV2 squared equals MV1 final squared plus 4M V2 final squared. Again, I can cancel the M's, and now we get two statements, two unknowns. And then some people, gosh, if we move the V1s onto one side, we get V1 minus V1 final equals 4 times V2 final minus V2. And then over here, we're going to get V1 squared minus V1 final squared. And we're going to get 4 times V2 final squared minus V2 squared. Now it's just a function of combining these two, right? Because here you get V1 plus V1 final times V1 minus V1 final equals 4 times V2 final minus V2 times V2 final plus V2. Right, we can factor that out is what I'm saying. Does that help us at all? What are our two unknowns? The two finals, right? Yeah. Yeah, we know the initial velocities of both. So let's see. If we put this into here, and we still have a V1 final. I'm missing the algebra here. There's a simple... I'll do this in yellow so that you don't think I'm smart. I don't want to take credit that I didn't deserve. Using the book, what's the equation? Times what? Oh, the initial.
And then there's another one. That's V2 final. Is 2M1
Is that applicable for this?
Well, you get both masses, right? Please say yes.
This is a perfectly elastic. Is this for inelastic?
This is for elastic. Inelastic is the final one is equal to M1 minus M2 over M1 plus M2 plus V initial. Times M1
2 V1 initial?
Because V2 is not moving with the table.
Oh, right. So they're both times V1, okay.
Yeah, so you find V1.
And then so what you have to do here is this was it 4 meters per second? And this was 1 meter per second. And then the relative velocity.
No.
Is this right? Yeah, I think this is right? Yeah. So then this becomes 3 meters per second. And this becomes 0. And then you can use those two equations. Oh, there you go. Sorry? Oh, because you're using this as the frame of reference. So you're putting the target on that one and saying that one is the center of the universe. Well, if this one's moving, then that means I have to subtract this speed from that speed. You know how it's like when you're on the freeway and you look at the car next to you, it looks like they're sitting still, but you're both moving. Okay, so that works. The what? How in the world did you do that? That's.
I got lost.
Oh no, I